Hey everyone, welcome back to my channel. If you are new here, I'm Shivani, a student diving deep into the exciting world of data science. I am thrilled to have you join me on this journey. This is video 7 in my data science series where we will be exploring key topics. Today we will be diving into the neural networks. So let's get started. Imagine, try to replicate how human brain works. In a machine, neural networks are designed to mimic the way our brains process information. They consist of layer of interconnected nodes or neurons which process data and learn patterns just like neurons in your brain. These models are the heart of artificial intelligence and power technologies like image recognition, voice assistance and even self-driving cars. So, why you should care about neural networks? Neural networks are everywhere, from predicting stock prices to detecting disease. From medical images, they are revolutionization industry. Learning how they work gives you a superpower to tackle complex problem and innovate in cutting-edge domain like AI and machine network. So breaking down neural networks, let's take a step on how neural network works. Input layer. The first one is input layer. This is where raw data enters the network. For example, in image recognition, the input could be the pixel value of an image. Second one is the hidden layer. They are the powerhouse of the network. Each layer apply mathematical transformation of the data, use weights and bias, helping the network learn patterns. The more hidden layer, the more complex pattern the network can capture. Third one is the output layer. The processed data from the hidden layer is converted into the final output. For instance, it might be predicted whether an image contains a dog or a cat or even output possibilities. So how does the neural network learn? Neural network learn through a process called training. Here's a quick breakdown how we can do that. First we move the data through the layers generating predictions. Second, the network compares its prediction to the actual result using a loss function. Third one is the network adjusts its weight and bias to the minimize error, improving this prediction. This cycle continues until the network performs to the desired level of accuracy. What are the applications of neural networks? First one, image recognition. Think about the app that can identify object or the faces in the photo. Next one, natural language processing. Neural networks enables chatbot, language translation, and sentimental analysis. Healthcare, they are used to predict disease and analyze medical images. Now let's see how we can implement the neural networks using Python. Importing libraries and preparing data. Let's build a neural network in Python using KS library. For this demonstration, we will be classifying handwritten digits from the MIS dataset. We normalize pixel values to the range of 0 and 1 for the faster and more efficient training. So, first we import library. TensorFlow is used for creating and training the neural models. So next one we load the MIS dataset, Xtrain, Ytrain. Xtrain is used for image training and Ytrain is the corresponding label for training images. The Xtest is for the image testing and the Ytest is for the corresponding labels for the testing images. Then we normalize our data. Pixel values in missed images range from 0 to 2 to 5. Dividing 2 to 5 is by normalizing these values to the range of 0 and 1, which is better suited for the neural network training. So let's run this code. This confirms that the 6,000 training images and 10,000 images testing images. Each image is 28 into 28 pixel in grayscale format. So the next step is defining the neural network architecture. Now we will define the structure of our neural network using KS. This will include a flattened layer of reshaped image data, two dense layer, one with 128 neuron and ReLU activation, and the output layer with 10 neurons. The flattened layer reshapes the 28 into 28 image into 1D array and the dense layer performs the computation to the learned pattern. So let's run the code. So here the layer type lists all the models in the with its type, that is flatten or dense. Next, the output shape shows the shape of the data as it flows through the each layer. Flatten converts 28 into 28 to 784, and dense condense gives the output of 1 to 8. Next one is the params. The number of trainable parameters in each layer is given. So in the flattened, there is no parameter, it is only reshaped data. Dense has 128 parameter. So so the total parameters are given here, and the trained parameters are given, and the non-trainable parameters are 0 because they are frozen. So the next step is compiling the model. We compile the model with the loss function, optimizer, and evaluation matrix. The Adam optimizer adapts the learning rate with Spark article cross trophy is ideal for multi-class classification. So let's run the code. Run the code. So here this model compile function configures the learning process for the neural network model. It specifies the optimizer, determine how the model adjusts its weight based on the loss. The loss function quantifies the difference between the prediction output and the actual target value. The matrices targets the additional performance measured during the training and evaluation. So the next is training the model. On the training dataset and evaluate how fast the dataset. We train the model for the 5 epochs, meaning it the process the entire dataset 5 times to adjust the weight. Let's run the code. Here, this line is responsible for the training of the neural network model on the training dataset while validating its performance on the last dataset and the each epoch. Let's break down what happened with each expected output. So Xtrain and YTrain, the training dataset and their corresponding labels. The model learns pattern in data by adjusting weights and minimizing its loss. Epoch equal to 5 is the number for the complete passes through the training set. For each epoch, the model updates its weight and evaluates its performance on the training and validation dataset. In the output, each epoch information indicates the training process and of the each epoch step-by-step total batch of the process data. So, it analyzes the trend of the training loss and the validation loss should decrease with more epochs if the model is learning efficiently. If the validation loss start increasing while training, the loss decreases, it indicates overfitting. The next one is the accuracy. Both training and validation accuracy should increase with more epochs. If the validation accuracy stop improving with the training, accuracy increases, it may indicate overfitting. The model.fit output gives a snapshot of the model learning process for the each epoch. The decreasing loss and the increasing accuracy over the epoch indicate the model is improving its ability to classify data correctly. Monitoring these metrics helps identify when to stop training or adjust hyperparameters. Next one is evaluating the model. Once we train, we evaluate the model performance using accuracy and classification report. The model's accuracy indicate how well it classified digits, and the classification reports provide precision, recall, event score for each class. So let's run this code. The output for the code block related to the training of a neural network using model.fit function provides a detailed summary of model's performance used during training and validation. Let's break it down with an example. So here's the output. So epoch progress indicates the model training for the first epoch out of total 5 epoch. So step per epoch, the number indicate the batch process per epoch. Next one is the loss. Loss is the value of the loss function applied in the training of the dataset means the error for the training set is 0.32. Accuracy, the proportion of the correctly classified sample in a training dataset. Accuracy should increase as per the model increases, and also the F1 precision recall matrices are given. So the next one is the visualizing result. Visualizing the model prediction. These visualization help us to where the model excel and where it may need the implementation. The output of model.fit indicates the model during the training and validation. A good a good model will show decrease in training and validation loss, increase in training and validation accuracy. Here, for each iteration of the loop, total 5 iterations will be following. A test image displayed for the dataset, a true label which represents the actual category of the image, and the predicted label which is the class predicted by the trained model. Visualization is a way to quantify excess model performance. It may predict are the incorrect, so you might need a fine-tuned model. So that's the wrap for the video. If you found this video helpful, don't forget to give it a thumbs up. So I will see you in the next video. Until then, keep exploring, keep learning, keep coding. Thanks for watching. Bye for now.